one of the pros for Postgres is it can be much faster when you have a lot of joins in your queries, because MySQL needs to first aggregate all the joined data into one table, and then it does the where clause on that completely joined table, which takes up a lot of time and a lot of space. Postgres manages that in a different way. So that is a thing where you might, or where you should consider probably, let's have a look at Postgres. And the main thing why you should at least try to use Postgres in a side project probably would be, I can only argue about something when I know it. So, of course, you can use MySQL for everything, but if you really want to have an option, you should at least know a bit of PostgreSQL, or Oracle, or MS SQL. But I think those are a bit too heavy for the most people here. Well, for the most people that are doing PHP. We have an application that runs on MySQL, and it has a lot of join operations in the select queries. And so I was looking for an alternative, and I was looking for at PostgreSQL, and it actually turned out we could reduce the select times by a factor of 1/3 just by using a different database, by using Postgres. And I just want to show you how I came to that point, what I had to achieve to actually get Postgres up and running, to log in, to create my tables, etc. pp, up to the point where I then could actually migrate my data in the end. So whoever wants to leave by now is free to do so. OK. First thing is I need to install Postgres. Postgres is available as a binary for Windows, Mac, Linux, whatever. Use your favorite installation tool on Linux, download it from postgresql.org, the binaries, install it. I think that's nothing that needs to be described here. And there are also some graphic user interfaces. Most of you are familiar with PHPMyAdmin, I suppose. And there is an equivalent one, which is PHPKonf. I never used it. I heard the interface is not as good as PHPMyAdmin. There is also a binary, a client for the machines, which is pgadmin, which is pretty good. It works on Linux, Mac, Windows, so I'm using that one. Works perfectly. But before I can use that, I have to run the server. I have to start the server, and then I need to be able to log into the server. And logging into Postgres isn't easy for a MySQL user. Who tried that? OK. So we all know this. On the console, MySQL, as a user, root, and we are up and running. There is the MySQL prompt. We can now select our database and do stuff, whatever. So I said, OK, I've installed Postgres server. Can't be that hard. Let's try it. PostgreSQL -u root. Nah, doesn't work. OK, OK. The command is PSQL. But still, the -u isn't not really an option. OK, PSQL --help. Read the manual. You should read the manual. And in that list, there is somewhere, OK, the correct one for the username is, OK, capital U. Thank you very much. So capital U root. No, doesn't work either. Because the role root does not exist. Wait a minute. In MySQL, we are using users. So you connect to the database or to the database server as a user. Postgres has a role-based access permission model. Postgres uses roles. What is a role? A role can be a user or a group. And the awesome thing is, roles can also be members of other roles. So I can have user roles, and I can combine them into one group role, and I can grant access to that group role, and all the users that are in that group have access to that database. And also a new thing for me as a MySQL user was database objects are owned by roles. Every database object has an owner. In MySQL, the owner is, well, MySQL. In Postgres, it depends. You can set an owner for any database object. OK, so roles. Wait a minute, there was something with Postgres as a user role. So I tried that one. PSQL -u Postgres. Peer authentication failed. Yeah, of course. Authentication must fail because I don't have a password. In MySQL, I don't need a password as a root user. Here, it looks like I need to use one. What? I need a password to initially connect to a database that I don't have? Can't really be possible. Well, it turns out those roles can be system users, but are not required to be system users. In MySQL, the database runs as MySQL user. In Postgres, the database also runs as Postgres user, the server. But the user can be a system user, and can be the Postgres system user, or it can be, well, a role I just created in the database. So the thing is, to connect to the database at the first time, I have to use sudo on a Linux machine or Unix machine. I'm not sure how that works on Windows, actually. And you have to make yourself the user Postgres. Sudo -u Postgres runs the next command as user Postgres. And then you say, well, I want to run Postgres as the Postgres user. And yes, logged in. It took me about half an hour to get to that point. Yes, we managed it. OK, so now we have a connection to the database from the terminal. But this is PHPKonf and not terminalconf. So I had to try that in PHP. So I create a new PDO object, PSQL. Host is 127.0.0.1. Port is 5432, which is the default port for Postgres. Much easier to remember, actually, than the MySQL port. And I'm connecting as the user Postgres. I don't need a password because, well, it worked in the terminal. Nah. Doesn't work. Postgres is about as nasty as MySQL in the default conditions. MySQL doesn't allow connections from outside your local machine, as well as Postgres. So I had to actually alter one of the configuration files. Here we have the listen address, which is by default localhost. So it only connects via a local socket. By the way, when you have questions, just show me, and I'll try to answer them. So what I had to do was I had to actually add listen address or addresses equals star. It's this one. And then I had to restart the Postgres server to actually be able to connect via a TCP socket. And then I also had to change this file, the PHPKonf. Here you see from where, which database shall be available for which user, from which IP address, and using what authentication method. And as you see here, all the local machines are available via peer authentication. Peer authentication is the mechanism that I use sudo -u, whatever user, PSQL. So Postgres then delegates the authentication of the user to the system, to the underlying system. I don't have to handle any passwords in my database, because I can use the system's authentication mechanisms, like PEM authentication, to delegate my authentication again to a different system, like LDAP or Active Directory, Kerberos, whatever you want. So I don't need to store passwords for the users in my database, which makes it pretty secure. But I have to change that file if I want to allow access from different machines. And I can also say, okay, if you want a local access, I want the users to be able to use an MD5 authentication, which means the password is stored in the local database. But then I have to create that user first. So I changed those files. And then I said, okay, now I should be able to connect to 127.0.0.1 with the user Postgres. And yeah, well, I don't have a password, so I try Postgres. But it still doesn't work, because now the password authentication failed. Because I didn't change that to MD5, it's still peer. Even if I changed it to MD5, I don't have set a password for that user. So the first thing to do is I need to create a role. So I log in as Postgres user on the command line, and then I call create role admin as a super user with a login password of, well, you shouldn't use admin, obviously. And then, when I created that role, I can use these credentials, these new credentials, admin and my password. And as I'm not getting any exception here, as I'm not getting any error, it works. Yes! Connected to the database via terminal and via PHP. Well, case closed. Dropping the role is about as easy. Drop role admin, and you're gone. But, well, you don't need that. How do you know what roles are available? In MySQL, you say, show grants, and you get a list of all the available grants on that machine. In Postgres, you need this \du, and then you get a list of roles. Postgres uses a lot of these meta commands. You know them from MySQL as well, \q, for example, or \dot to read a file. But Postgres uses a lot of them, and your friend is \?, because it gives you a list of all the commands, of all the meta commands, and that's a long list. I'm not printing that here. And that's that. If you want to read further stuff on that, have a look at that website. It's the current PostgreSQL documentation for Postgres 9.6. Postgres by now is a bit more stable than Rasmus told us this morning. It was 25 years ago. Well, I'm not sure. I don't have an internet connection, but we can later on have a look at whether it has limit or not. But I'm pretty sure it has. And you know why. So the first thing is we have connected to a database. Now we need to create a new database. There is a difference between MySQL and Postgres here as well, because in MySQL, I connect to the database server, and then I use a database. Fair enough. And if I want to use a different database, I just say use different database, and you're set. In PostgreSQL, you connect to a database. You can do that in MySQL as well, but it's not the default. In Postgres, it is the default. You say, I want to use this database, and if you want to switch to a different database, you have to log off and log on to the next database. There are some exceptions to that rule. I'm getting to that later on. Yes, that was my first impression. OK, how do I know what databases are available? In MySQL, I log in. I'm not saying use. I'm just saying show database, and I get a list. Fine. Yes, you guessed it. There is a backslash command, which is \l in that case. And then you get a list of databases. This is one of the exceptions. You need to connect to a database. As you usually use the user Postgres, there is also a database named Postgres, which is created on setting up the server. And when you are connected to a database, you can use this meta command \l to get a list of all the databases that are available. Then you have to log off and log on again to use your database. What databases are available by default? Postgres, the database named Postgres, is created on installation. And when we have a look here, there are 3 databases in here. It's the Postgres database, it's the template 0, and the template 1. Just as a reminder, in some default installations, they are all set to Latin and English US. So if you want to use UTF-8, which you should, you have to change that. We come to that later. OK, so Postgres is created on installation. Then there is a database named template 1, which is a default template that is created, that is used for all databases to come. So when you create a database, you basically create a copy of template 1. And then you can change that. All changes you do on template 1 are automatically copied to all new databases. We're using that feature in a minute. And template 0 is also available. Template 0 is, well, as well a copy of template 1, but it should never be touched. So you have a backup. If something goes wrong with your template 1 database, you can always roll back by deleting template 1 and copying it fresh from template 0. OK. Never alter template 0. Now, we create a database. Create database, my new database with owner admin. There we have the owner. From the template, template 0. And the encoding should be UTF-8. And the LC type should be English US UTF-8. And the collation should also be English US UTF-8. Use your collation and C type of preference. But please use UTF-8. Can't stress that often enough. And then it creates a database. And then just have a look, \l, and this one. Here is my new database. Owner is admin, and the encoding is UTF-8. Great. Set, ready to go. This is a bit long up there with owner admin template, encoding, and stuff like that. As I said, we can change the default template. So the first thing I did was I updated this database and set the encoding to UTF-8, where the database name is template 1. And when I do that, I've changed my template to always be UTF-8. I don't have to think about it anymore when I create a new database. It will always be UTF-8. Are you with me so far? At least no one is saying no. OK. Removing the database is equally easy. Drop database, my new DB, and it's gone. I'm not sure you need that. This can only be done by the super user, so by the Postgres user, or by the owner. And it's a pretty dumb idea to delete a database you're currently connected to, isn't it? So this is a command that can only be done when you connect to a different database. Yes, connect yourself to Postgres or to template 0 or template 1, and you can delete that database. So creating databases or managing databases, there is also a documentation entry, pretty exhaustive. Yes?
What is template?
Sorry?
What is template?
One of those template databases. The template 0 or template 1. Those are, I showed you the three data. Let me here. These three databases: Postgres, template 1, and template 0. Those are actually three databases. Postgres database is created by installation. Template 1 is your template database from which every other database is created by default. And template 0 shouldn't be used. But those are databases as every other database as well. You could use them in production for your production data. It wouldn't be wise because everything you have in template 1 will be copied to another database if one is created. But it's perfectly possible. Whether it makes sense is a different story.
Could you show us the slide when you have create database?
This one?
Yeah, but it uses template 0.
Yeah, I'm using template 0. You're perfectly free. You can use every database you have in Postgres as a template. So when you have a production database and you want a staging database with the same data as your production database, it's perfectly valid to create a new database with a template of your production database. And everything will get shoved over. It might take a bit of time, yeah. That's a different thing. But that's possible. You can use every database as a template for creating a new one.
And does it have any tables in it?
It has some tables in it, yeah. Though I'm not sure which ones, but there are some. Yes?
Has MySQL something like that?
I haven't found it, actually. Well, in MySQL, you create a database from scratch. There are no tables and nothing in it. Because you say create database, and then it's empty. And you set the collation and encoding stuff and stuff like that. You set that in the table, but not in the well. You can set it also on the database level, but here that's inherited to all the tables. So where were we here? Okay, so now it's time to create some content. Create some content. Okay, creating tables is pretty easy. Most of you know that from MySQL. Create table foo, bar is an integer with the primary key, bar is an integer, text varchar 255. Well, works in Postgres as well. But have you noticed something? Just show you again. Have you noticed something? There is one backend in Postgres. When I'm creating a table, I don't have to say use myISAM or use InnoDB or use whatever. They have one backend and one backend only. As far as I know, there are some companies that created their own backends, but those are companies like Facebook. So it's under normal circumstances, it doesn't make sense to create an own backend. They have Postgres has a backend, and it works. It just works. And there is also one thing. When I'm just switching back, I'm saying here, create an integer with the primary key. But I'm not saying auto-increment anything here. In MySQL, we would say, yes, auto-increment this primary key, starting from 0 and then go up. That doesn't work in Postgres. That's the thing most users that are coming from MySQL are really annoyed of. Because in Postgres, we need to create a sequence. And we need to create that sequence first with create sequence. And then we create the table and tell this integer primary that the default should be the next value from that sequence. And in the end, I'm saying alter the sequence that it is owned by foo.bar. So the sequence is owned by this field. Why is that? Pretty cool. As soon as I remove that field, the sequence is also deleted. Otherwise, I have to delete that sequence myself. I can also use serial. But serial only actually works for integers. When I use a sequence, I can also concatenate that. I can use a function to create my new sequence ID. But be careful. MySQL uses the auto increment feature, and you get always the next ID from the last one. Sequences might fail when you add IDs manually, because you can add an ID manually, no problem. Let's say you have a sequence, and the sequence ID, current sequence ID is 3, and you just say, okay, I just insert 55 as an ID for my next insert. And then everything else will work perfectly until you get to 54. And then the next insert would be 55, but 55 is already taken, so it will fail, because there is a duplicate key. So in MySQL, the next ID will always be highest ID plus 1. Postgres will use next sequence ID. The sequence doesn't know that you inserted something else in there. And sequences will skip numbers when the entry fails. So when you do an insert that fails, the sequence still has taken the number. So it might happen that numbers are skipped. OK, so are you with me so far? Good. Data types are a different thing. There are some differences in data types between MySQL and Postgres. One, and that was the one I was looking forward definitely, is Postgres knows Boolean as a data type, an actual Boolean, though it does not have any tiny data types. So when you have tiny tables in MySQL, forget it, just use the corresponding default value. So instead of a tiny int, use an int. And Postgres doesn't use unsigned. So if you rely on an unsigned ID or unsigned values, you should use the next higher data type possible in Postgres. Floats are called real. Anything with text at the end, like small text or tiny text, is just known as text in Postgres. Blob is called byte A. OK, we can live with that. And datetime is called timestamp. OK, we can live with that, no problem.
What they call timestamp?
Hmm?
There is timestamp in MySQL which corresponds to.
Let's get into that in detail later. Because datetime, timestamp issue is a different story. OK. So we've been to an index. We've seen we can use a primary key index. Every other index that we can create in Postgres by just appending unique or something else to the table definition needs to be created separately in Postgres. You can do that in MySQL as well, and you should do that in MySQL as well. So here, I have to create a unique index on foo bar. So OK, I'm creating a unique index on that serial ID. Pretty cool. Yeah, we know that. The thing is, in Postgres, I can also say, what kind of index do I want to use? And that is pretty nifty. Because I can here say, you know, this foo field should be indexed using gin, OK? And the nulls should be last on the field text. No, on the table foo field text. So what is gin? Gin is one of the possibilities how you can create an index. A lot of you might have heard of a B-tree index or of a B-tree structure, which can be used to index data. And the same applies to hash, to gist, to spgist. Gin is also one of them, and brin. Rumor is that gin was developed by some Russian guys, and they didn't find an acronym for vodka. And you can also say, how should that be ascending or descending? And you can also tell the index, hey, give me the nulls as the first values or give me the nulls as the last values when I'm searching something. And that is pretty cool and pretty amazing. You can do a lot of awesome stuff with that, but you need to get into that pretty deep. Yes, it's a database for grown-ups. GIN is the general inverted index. Full text search, for example, uses that. Postgres is, from what I've encountered, a bit stricter in type checking than older MySQL versions. But on the other hand, you can use type conversion within your SQL statements. That was just something I stumbled over when I migrated. So, and that's the last point. You want to migrate to PostgreSQL? No? Well, I should at least think about it. There is a good page converting MySQL to PostgreSQL, which more or less contains all the information you need for that. Beware of one thing. Once you converted your data from MySQL to Postgres, which is rather easy, it will be pretty difficult to migrate back. Because there are different data types, there are more data types, the indexes are completely different created. But on the other hand, when you migrate to PostgreSQL, I've never heard of anyone migrating back. So, how does a migration work? Basically, it's just MySQL dump, Postgres compatible. Who of you knows the compatible flag for MySQL dump? Okay, at least something you can take home with you. You can tell MySQL dump to dump that data in a compatible format for PostgreSQL, for Oracle, for whatever. And the way the data is exported will be a bit different. For example, by default, MySQL uses double quotes for strings. And as Rasmus this morning told us, you should use single quotes for strings in SQL. So when you're using this flag, MySQL dump actually does that the correct way. Then you use a converter script on that dump, which is linked in that page. You prepend that dump with set standard conforming strings off and set \quote on to fix some issues that might happen during that import. And then you import that into Postgres via PSQL-F import SQL, or whatever your SQL file is called. And then you hope and pray. This might take a while, and it might fail. So you have to rinse and repeat them. There are some ways how your specific data might need a bit tweaking. The converter script that you can use on that dump doesn't probably handle all the use cases, especially in your case. So you might have some handwork there that you need to do. But when you're done, it's pretty awesome. Yeah?
Why should I use converter script if I already have dump compatible?
Because the dump from MySQL, for example, contains tinyInt as table definition.
So
The export is compatible with Postgres in terms of, for example, string handling and stuff like that. But it still contains the fields you created in the tables. So when the tables were tinyInt, MySQL then doesn't convert that tinyInt to integer. There is still a tinyInt. So that converter script converts tinyInt to int, converts whatever to whatever else. There are different things, \conversion and whatnot. It's a pretty awesome tool, written in Ruby or Python. No, Python, I think. And it handles a lot of stuff, but it took me 2 or 3 goes to actually get all the data into my database.
Did you use SED?
I also used Z, yes. But I can tell you, using Z on 8 gig is an interesting challenge. Okay, there is also a kind of migration way. Postgres can use other databases or other data backends as input. Foreign data wrappers is a pretty cool thing that was introduced in the SQL standard some years ago. So Postgres is not the only database that knows that can do that. Oracle, for example, can that as well. But it allows you to create a database in Postgres and tell Postgres if this table is used, take your data from somewhere else. So you still have to create the table in Postgres, but you just tell it you're not storing the data here, but you're redirecting the data to somewhere else. And that can be MySQL as a backend. That can be any other database. That can be even Postgres. That can be an LDAP. That can be a CSV file, whatever you want. So it's not really migration, because your data will still be in MySQL, but it is a way to use your data via Postgres.